bypassing the Santa Lucia Dam. One of the fundamental pillars on which the functional integrity of a river rests is that of river connectivity. Rivers constitute essential corridors in which all the species of an ecosystem interrelate. Artificial barriers in a river impede many of the biological processes that are crucial for maintaining the hydromorphological and ecological equilibrium of an ecosystem. Recent years have witnessed numerous advances in environmental measures and actions aimed at restoring longitudinal connectivity and enabling the passage of all species along a river. Notable among these is the construction of naturalized passageways for fish and other aquatic fauna. However, the naturalized passageways built to date and conventional fish ladders alike only appear feasible for small obstacles, whereas large dams seemed impossible to bypass, suggesting that the environmental degradation they cause is unavoidable. With the aim of bypassing large barriers in an environmentally friendly manner and with an appropriate cost-benefit ratio, the DRBA has launched a pilot project in the Garganta del Entrenal in the province of Avila to bypass a large 29-meter-high dam. The Santa Lucia Dam was built to supply water for irrigation and forms an insurmountable obstacle for all the fish species present in the area, many of them Iberian endemisms exclusive to the Duero Basin. It also hinders the passage of the Iberian desman, which is of particular concern because the gorge hosts one of the last surviving populations of this small aquatic mammal in the central system. River restoration works began in 2018, and unlike previous actions based on elements such as mechanical devices, this is the first project in Europe to attempt to bypass a large dam using a naturalized passageway that is also aimed at restoring some of the habitat lost as a result of dam construction. Construction of the channel connecting the dam wall area with the upper part of the reservoir posed a series of technical challenges requiring constant adjustment of the project. With an approximate length of 1.8 kilometers, the channel needed to have sufficient slope to create a suitable habitat along its course for fish and other aquatic species likely to use it. In this case, the main difficulty lay in the scant difference in elevation between the two ends of the channel, necessitating rigorous construction and constant adjustments. In addition, the morphology of the channel had to be as irregular and varied as possible, with alternating areas of faster and slower flow in order to generate a diversity of habitats, not only for fish, but also and fundamentally for the various plant and macroinvertebrate species that would ultimately provide shelter and food resources to support an entire river community identical to that in the unaltered section of the gorge. One aspect that was expressly planned was the existence of spawning, shelter and resting areas for the fish, which was achieved by the alternation of environments. In addition, under the supervision of experts, shelters have been installed made of natural materials such as trunks and branches, which are aimed at promoting the presence and safe movement of the desman along the channel. While adjustments to channel slope and layout were being finalized, and the first tests were being carried out on the circulation of the different flows, work began on construction of the fish passage. Until now, no project had ever attempted to bypass a barrier of this size, let alone to create a naturalized passageway. Drawing on the DRBA's experience in the construction of this type of element in other river systems, an over 300-meter-long zigzag fishway was designed to bridge the 29-meter difference in height from the river to the crest of the wall. Several rest areas were interspersed along the fishway to allow the fish to recover their strength before continuing along the route, which poses technical as well as biological challenges for aquatic species. One of the main technical challenges was to create a route along the valley's slope with mean gradients of between 5 and 7% and at no point exceeding 10%. After calculating the route, the construction and adjustment of each of the ponds required constant monitoring and correction of the conditions generated by project execution, entailing meticulous work pond by pond. Once the channel had been excavated, a substrate of different sized gravels was laid to minimize transport of materials from the passageway and promote a more irregular and slower flow within it. Then, the weir that retained the water in the channel was opened to confirm that the fish passage was working as expected. However, simply checking that the water was flowing properly through the fishway pools did not answer the fundamental question of whether the fish would be able to use the passageway for migration, an aspect in which many barrier bypass projects have failed after investing considerable sums. Thus, once the fishway had been tested for proper hydraulic operation, it was necessary to determine whether the fish were capable of surmounting the difficulties imposed by such an ambitious design. To this end, a monitoring program was launched based on electronic tagging of fish. Initially, a sufficient number of specimens were captured, tagged, and then released, enabling detection of their passage by means of special antennas placed along the entire length of the fishway and channel. This enabled detection of the passage of specimens at each of the points established along the fishway and artificial channel, thus confirming the feasibility of the passageway. Following an exhaustive process of design, development, and adaptive management of the Santa Lucia Dam Fish Passage, it has been demonstrated that naturalized passageways are an effective means of bypassing large barriers at low cost, while at the same time restoring some of the habitat lost through construction of the reservoir. In the second year of operation, the changes within the channel are clearly evident. Macrophytes have colonized parts of the channel, promoting the establishment of macroinvertebrate species and increasing the availability of shelters and ecological niches that are used not only by strictly aquatic species, but also by other faunal groups of interest. As a result of successful repopulation and natural recolonization, the banks are gradually integrating the channel into the landscape, which is beginning to look very similar to a natural system. Monitoring results suggest that species such as trout are capable of ascending and descending the fish passage without difficulty in relatively short periods of time. Moreover, the fish not only use this newly created habitat as a means of passage from one stretch to the other, but also occupy it at different times of the year in their natural biological cycle, as it now forms part of the gorge itself. The action carried out in Santa Lucia presents a model of action in accordance with the objectives pursued in river restoration and compatible with the socio-economic use of river ecosystems in the 21st century. With this project, the Duero River Basin Authority has once again demonstrated its firm commitment to the restoration of river connectivity in the Duero Basin, regardless of the difficulty involved or the magnitude of the challenge posed, implementing innovative solutions that respect river dynamics and associated biological processes.